Question number 1. We have an equation y equal to x squared 2x plus 1, and we are going to find the value of x that satisfies this equation. Alright, so we need to find dy dx and as well as the second derivative. Product rule, x squared times 2 plus 2x plus 1. Okay, so 6x squared plus 2x, this is dy dx, the first derivative, and the second derivative, d2y dx2 is equal to 12x plus 2. Alright, so the equation, so we replace the value of d2y dx2 and dy dx into the equation. Okay, so open up the brackets. Equal to 0. Okay, so 12x squared minus 12x squared, and left with minus 2x plus 8 equals 0. So 2x is equal to 8, and as such, x is equal to 4. Alright, let's move on to the next question. Question number 2. Find the maximum minimum points on the curve y to 1 plus 12x plus x squared minus 2 over 3x cubed. Okay, derive it. Equal to 12 plus 2x minus 2x squared. Let's factor out 2. That becomes 2. 6 plus x minus x squared. And we are going to find maximum and minimum points, that is the turning point. So at turning points, dy dx is equal to 0. And as such, 6 plus x minus x squared is equal to 0. So if we bring 2 over to the right, then it cancels. So we are left with 6 plus x minus x squared equals 0. And we can change the sign, that minus become plus and plus become minus. So that becomes x squared minus x minus 6 equals 0. From here, I think we can factorize. Yeah, and as such, x is either equal to minus 2 or x is equal to 3. And if x is equal to minus 2, then what is the corresponding value of y? Then put it back into the original equation. 12 multiplied minus 2, that is minus 24. And minus 2 squared, that is plus 4. And minus 2 cubed, that is minus 8. And times 2, that becomes plus now. 16 over 3. So that equals, let's use calculator for this. 1 minus 24 plus 4 plus 16 over 3. That is minus 41 over 3. And if x is equal to 3, then y is equal to 1 plus 12 multiplied with 3. 3 squared minus 2 over 3, 3 cubed. Alright, so that 3 here, so we can reduce that by 2. So that's equal to, I'm going to need more space. 1 plus 36 plus 9, and this is minus 6, minus 18, because 3 squared is 9 multiplied by 2, that is 18. So that is 1 plus 36 plus 9 minus 18. 28. So we have two turning points. Minus 2 minus 41 over 3 and 328. So these are the two turning points, but we do not know which one is minimum and which one is maximum point. And we need the second derivative, d2y dx2. Well, what is dy dx? Let's take a look again. Here, dy dx is this. So d2y d2x is gonna be 2 open bracket 1 minus 2x. To 1 minus 2x. To determine whether or not there are minimum or maximum point, then we need to evaluate the value of the second derivative at each point. So for the example, x is equal to minus 2. We do not need to evaluate the value, but we need to know whether or not they are negative or positive. So what's the value of d2y dx2 at x equal to minus 2? 1 minus, okay, minus 2 times minus 2, that is plus 4. Or 2 times 5, which is 10, plus 10. That does matter. That is the only thing that matters. Plus. We do not care about the value 10 over here. And at x equal to 3, that is 2, 1 minus 6. Okay, 3 times 2 is 6. So that is minus 5. Minus 5 times 2, that is minus 10. So this one is plus, this one is minus. What does it mean? It means we have the minimum point, that is minus 2 and minus 41 over 3. Let's draw the conclusion here. Therefore, the minimum point is minus 2 minus 41/3, and the maximum point is 328. Okay, that's the answer for question number 2. And move on to the last question, question number 3. Find the turning points of the curve y to x plus 1/2x squared and determine the maximum or minimum points. Y equal to x plus 1/2x squared. So dy dx is equal to 1. Oh yeah, I need to change it into this format. X plus x to the power of minus 2 over 2. That will make my life easier. So minus 2 bring down to become minus 2 time divided by 2, that is become minus 1 only. And that now minus 2 minus 1 become x to the power of minus 3. So that is 1/x cubed. As usual, at turning points, dy dx is equal to 0. So 1 minus 1/x cubed is equal to 0. Moving minus 1/x cubed over to the right, so that is equal to 1. So x cubed is equal to 1. And x is equal to square root, not square root, cube root of 1, which is also 1. So what is the corresponding value of y? Put it back into the original equation. 1 plus 1/2 1 squared. So 1/2 1 squared, that is 1/2. So that is equal to 1 plus 1/2, that is 3/2. So there's only one turning point then. Only at 1, 3/2. So is this coordinate minimum or maximum? Then we need to evaluate the second derivative. Giving myself more space. This is equal to, well, differentiation of 1 is 0. Minus 1/x cubed. That is minus x to the power of minus 3. So that becomes minus 3 times minus 1, that becomes 3 over x to the fourth power. Okay. So at x equal to 1, d2y dx2 is equal to 3 over 1 to the fourth power, which is equal to 3. And it is a positive value. Therefore, the coordinate is a minimum point. 1, 3/2 is a minimum point, or a relative minimum point. Okay, that's the completion of quiz 11 with all 3 questions. I hope you have got all the right answers. So see you soon. Bye-bye.